Lesson 70 is going to be about finding surface areas and volumes of prisms and lateral area. And first of all, let's look at, I said prisms, I mean pyramids. Let's look at a pyramid here. Well, on this pyramid, I want to label a few things. The first thing is the base. Now notice the difference between a cone and a pyramid ultimately is the base. It's all about that base. So the base in a pyramid is going to be a prism, or sorry, a plane compared to a cone which has a circle as the base. So there's your base. It is always opposite of your vertex. Your vertex is where all your lateral faces meet. Your lateral faces are what goes kind of around the sides here. And so your lateral faces here are triangles. Ironically, your base is also a triangle. But those are your lateral faces. They all meet at the vertex. And then the last part is the slant height. The slant height is the line that connects from the vertex to the midpoint of the opposite side, and it creates a perpendicular angle. So now that we got our definitions here, let's look at a few formulas. The first one is lateral area. The formula for lateral area is 1/2 times the perimeter of base, that's perimeter of base, times the slant height, and you know what that is. L is actually the abbreviation we use for slant height. So we solve, we do lateral area equals 1/2 perimeter. Well, this is a 5-sided polygon, so, and it's regular. Did forget to say that. It's a regular polygon, so all the sides are the same, so we can do 5, number of sides, times 2, the measurement. 5 times 2 would be 10. And then it just gives us our slant height is 5. So we do the math. 1/2 of 10 is 5. So 5 times 5, 25 centimeters squared is our lateral area. So that's how you do lateral area. Surface area is the lateral area, what we just did, and then just adding the area of the base. So we start by doing our lateral area, and that is 1/2 perimeter times slant height. Okay, well, what's our perimeter? Our shape of our perimeter is a hexagon. It's got, I believe, 1, 2, 3, 4, 5, 6. Yep, 6 sides, and the side length is 3. So our perimeter equals 18. Plug that in, 1/2 of 18, and it just gives us our slant height again. That's very nice and kind of them, and that is 12. So we do the math there. 1/2 of 18 is 9. 9 times 12, remember right now we're only finding the lateral area. 9 times 12 is 108. 108. So, okay, I'll go ahead and erase this and plug in 108 for L. So we just found lateral surface area. Now we got to find the area of the base. Well, if you look at the base, it is a hexagon. It's a regular hexagon. And if you remember a couple of lessons back, we did area of regular hexagons and how to find those. And our formula was the area equals 1/2 apothem times perimeter. Well, we already know what our perimeter is. It's 18. We did that. Now we got to find the apothem. Apothem goes from the midpoint of one side to the center and creates a perpendicular line. There's our apothem. So how do we solve for that? Well, what we do is we create our little imaginary triangle here. And what we did when we created a triangle between two vertices is we created a central angle. Now our central angle, the formula we had there back in investigation 3 was 360 divided by number of sides. Our number of sides is 6. So 360 divided by 6 is 60 degrees as our central angle. Now we take that big triangle and cut it in half. And let's see what values we have. Well, we cut the central angle in half, so therefore this is 30. That's 60. The base measure was 3. So when we cut that in half, it's 1.5. And we're trying to find the apothem. Don't care about the hypotenuse. 30, 60, 90 triangles, so that's nice. We have our little shortcut there to get from a short leg to a long leg. If you remember 30, 60, 90 triangle principles, we simply do 1.5 times radical 3. And that's all it is. There's our apothem. So now we can plug that in here. And we're running out of space. So since we're running out of space, I'll put it over here. I'll do surface area equals 108 plus 1/2 times 1.5 radical 3 times 18. Okay, 1/2 of 18 is 9. And 9 times 1.5, let's see if it wants, yeah, we're going to get rid of the radical 3 since it wants it in decimal form, I guess. So 1.5 radical 3 is 2.59 yada 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 times 9. And that's 23.38. So we add that to 108 and get 131.38. And our measurement is centimeters, so it's centimeters squared. That's how you do surface area for a pyramid. The last formula we're going to look at is volume. The formula for volume is the area of the base times the height. Or sorry, 1/3 the area of the base times the height. Now, height is something different. We haven't really looked in at pyramids yet. We've looked at slant heights. A slant height was where you went from the vertex to the midpoint of a side. However, the height is when you go from the vertex to the center of the face of the base, and it is perpendicular. So now, that changes things. Our height is actually the altitude. You can call it the height or the altitude, but it is not. The slant height is what you need to know. So now let's look at one example. Example 3. It wants the volume. And we know volume equals 1/3 area of the base times the height. Well, area of the base here is a triangle. We like area of a triangle. That's easy. 1/2 little b times h. Our little base is 8. Our height is 5. Sorry. 1/2 of 8 is 4. 4 times 5 is 20. So the area of the base, I put A for area, but it's really big B, is 20. And our height, it gives it to us. It's our altitude, that is 9. And then we simplify. Well, I can do 1/3 of 9. 9 divided by 3, or 9 times 1/3 is 3. And 3 times 20 is 60. 60 inches, and since it's volume, it is cubed. That is how you do finding the area, lateral area, surface area, and volume of pyramids.